Good afternoon, everybody. Thank you so much for joining us for the third session on this fourth day of the 17th Vermont Organics Recycling Summit. The summit is organized by the Composting Association of Vermont in partnership with the Vermont Agency of Natural Resources. And I probably know all of you by now, but I am Natasha Duarte, the director of the Composting Association of Vermont. This event is being held as a kickoff event for International Compost Awareness Week, which starts on Sunday. And it's the most comprehensive education initiative of the compost industry. The theme for this year that we also adopted is for healthier soil, healthier food, compost. And for each session, I've been cycling through some of these fabulous posters that UVM students created as part of Dr. Deb Nair's Composting Ecology and Management class. And the full collection is available on the CAV website at compostingvermont.org/VORS. So just a quick shout out to those folks. I also want to give just a huge thanks to all of our sponsors. Many of them are perennial, coming back year after year, and they're really allowing us to provide this full week program free of charge to our participants, increasing access to all of this great content that we have lined up for you. Our sponsors this year include Community Bank, Nature Cycle, Eco Products, Vegware, Addison County Solid Waste Management District, AgriLab Technologies, Vermont Natural Ag Products, the Vermont Produce Program of the Vermont Department of Agriculture, Food and Markets, and RMI, Building Healthy Soils. So once again, just join me in saying a thanks to them for helping us put this summit on. We are here today at the final session of the day. From erosion control to managing challenging pollutants, compost-based products excel at stormwater management. And we're joined by Jack Eaton of Filtrexx Northeast Systems. And I'm going to stop sharing my screen and invite Jack to share his while I introduce him. So Jack is the technical sales support representative for Filtrexx Northeast Systems, the Northeast manufacturer of Filtrexx filter socks, based in Goffstown, New Hampshire. Jack has been CPESC since March of 2007 and has worked in erosion and sediment control for over 15 years. His work is focused on providing green technology solutions for more cost-effective stormwater management during construction, as well as post-construction applications in sustainable site development and green infrastructure systems. And just on a personal note, I'll just say that I've worked with Jack on a few different things, different projects, and he's a fabulous wealth of knowledge with a whole lot of just real on-the-ground experience. So thrilled to have you here with us, Jack, and folks in the participants. Use his knowledge. You have him here for an hour and a half or so, and so if feel free to ask your questions to get the most out of this session. And with that, I'll turn it over to you, Jack.
Beautiful. Thank you very much, and thank you all for coming. That was quite a build-up, so I hope I can live up to everything that she had to say there. But so we're going to talk today about compost and composted products. Okay, I'll get into that a little bit more as we go along here. But really, we're looking at trying to find natural ways to solve problems in the environment and use more naturally occurring things. I'm going to talk quite a bit about that. I think there's a big shift in this industry right now to going to not only biodegradable products inside the netting, but making that netting biodegradable when possible as well. So two pictures here in the front, one from New Hampshire. The lake in the background there is Lake Winnipesaukee. The picture on the other side, on my right, is South Stratford, Vermont. That is the Elizabeth Mine, where I spent a good 10 years doing erosion and sediment control. And you're looking at a whole field of seeded area with erosion control. Excuse me. basically we're putting road bumps down through there with these are straw wattles, biodegradable straw wattles. So we're put all of that in. Once the grass comes in, the rest of that can be left. I like to remove the stakes. I think the stakes are a hazard, but the rest of it can stay where it is. So just something to get started with. When I got into this business, I was always like the biggest expense. Why are you always such an expense? Well, I was an expense because I'm coming in to fix a problem after you've tried to do something else. And now you're starting to see more and more people using these products and these techniques and finding that actually they save money in the long run if we do them properly in the first place. Just a quick thing. I know we all know this, but the world's covered with water. Why do we have such an issue with it? Well, when you break it all down, there's really only 1% of the Earth's water that's suitable for drinking water. Okay. So it's really important that we try and conserve those resources. So old school, we used hay. And we used a lot of hay. And I've done all kinds of creative things with hay to control erosion and sediment on job sites. But it was never really designed as an erosion control tool. It's designed to gather, transport, and store forage for farm animals. And it has some issues when it comes to using it for erosion control. Like I said, a hay bale was never really designed as an erosion control tool. There are gaps every 30 inches. Water can get under them easily. They're not easy to install. If we install them properly, we're digging them in 4 inches into the ground in a trench. And really, they act more as a dam than anything else. Now, I'm not saying if the only thing that you have at hand is a hay bale that you shouldn't use it. But I think in today's world, there are a lot of products that are more designed to be used for erosion control, and I think that they're more readily available now. So this guy loved the hay, and he's exactly what it was used for. This was at a stormwater meeting that we did years ago at a petting zoo, and they let this guy roam the property. He came over and he was eating my hay bales as well as the donuts and everything else that he could get his hands on. They're not they're not great for perimeter control anymore. All right. We've used them for years as perimeter control, but honestly, the cost of a bale of waste hay has gone from about $1 a bale when I first started in this industry to I've heard as much as $5 or $6 a bale in some parts of New England. So just from a cost standpoint, these products are starting to become less effective than they used to be. And then there's this. So what are we replacing? We're replacing silt fence in most cases. All right. And I get around on a lot of sites. I just happened to run across this one day. I wasn't even doing erosion control in the site. We were doing a landscaping project, but I walked out in the woods and I found this. This is silt fence. It has to be at least 10 years old. Was not removed the way it should have been at the end of the job site. And it's hanging on those trees because they installed the silt fence in front of those trees and cut all the roots on one side of the tree. So you can see some of the roots that they cut off there. And therefore, there's probably 6 or 8 trees there that are in a row that all wind dumped because of the silt fence that was putting in. So to try and save the environment, we're actually doing some damage to the environment. And certainly in certain cases, it's very difficult to install this and not do damage to exactly what you're trying to do. So what came next? My friend went over the straw wattles, couldn't do much with the straw wattles, but enjoyed scratching his head on the stakes. When I started doing this, primarily what we were doing was seeding work and perimeter control. And now you look at, all of these different functions that we have to somehow deal with using these erosion control products. And we'll talk about some of this. We're into heavy metal removal now and different sites. I was talking to someone today about a mustard factory that has a pH problem that we're going to try and do some work with. So all kinds of different things that we're doing now that we weren't doing even 5 or 10 years ago. So lots of different products. When I first started doing this, We use blower trucks and HDP plastic, which is high density polyethylene plastic. It photodegrades in about a year or two. But as we'll talk about here, photodegradation doesn't mean that it really goes away. So there's polypropylene now, there's wax cotton, there's burlap. We're looking at deconstructed wood fiber meshes now. Straw wattles used to only come in HDPE plastic. We now make them in a polypropylene if you have a really difficult site, or cotton is becoming very popular now. So again, so I want to talk about straw just a little bit. I know most of you are from Vermont, so you probably got a good idea of what this is about, but for the purposes of this conversation, straw is agricultural straw, a byproduct of manufacturing grains. We do some of it here in New England, but it's primarily, most of the straw that you see in New England here is coming out of Western Canada, and maybe the Western, US. Western Canada for us happens to be the best transport. In the United States, we use mostly all trucks. Canada still uses a lot of rail, so it's relatively economical to get straw out of Western Canada to Quebec, and then we actually pick our straw up in Quebec. We're using locally sources when we can, but we're using enough straw that we're required to do that. Hay, why do we use straw instead of hay? Hay is everything in the field, whatever happens to be there. If I'm doing some sites, and I used to say this about the Southern Loop when I was working on the Southern Loop, we used hay for all of our mulching work, and except in a wetland. If it was a wetland, we'd use straw. I grew all kinds of things with it. We're not in the seed mixes that we used. Some of those were actually better than the seed mixes that we used, but we grew a lot of things there. They didn't care as long as there weren't invasive species, which we worked hard to make sure that we never got, as far as I know, we never got any on that job site. But it's certainly a problem really with any of these products. If we take a big field, if we're not careful, there's always the possibility of having some kind of invasive species in there. So that's why we use straw. And excuse me, the straw that we use is inspected by crop scientists in the field before harvest. We inspect bales as they come into our facility. So there's a chain of custody there, so that we have a good idea of exactly, any potential problems. And honestly, if I have a problem with straw, it's probably the amount of herbicides that are used on straw. I mean, on grain products in their production. I'm more worried about that, honestly, than I am of having an invasive species. But it is one of the things that we use quite often. We make a fair amount of straw wattle. You'll see, again, you're starting to see a lot of different nettings used. So HDPE plastic is very inexpensive and is used in a large amount of the straw wattle that's made in the United States. But we're starting to see cotton. I've certainly been pushing cotton for quite a while. And again, we're looking at some other organic fibers that will break down in the field. And but honestly, for straw wattle, the straw inside the wattle and the cotton on the outside decompose at about the same rate. And it seems like a no-brainer to me that if I don't have to go back and pick up that netting, which you do in Vermont and which you will in a lot of states, more and more we're starting to see that you have to recover all of that. So that minor cost, maybe about 20% difference in cost, gets eaten up pretty quickly if you've got to go back and chase all of that plastic. This is what a straw wattle would look like. As opposed to a hay bale, they're uniform in size. They're relatively free of seed. There's always going to be some of that grain in there. I get panic phone calls all the time. There's things growing out of my wattles. It's grain. It's never going to mature. You're not going to have a problem with it. But there always is going to be some seed. It's going to be free of invasive species for the most product. And it's we could argue this point, but it's a waste product of grain production. All right. I could make an argument that it's probably better leaving it in the field and turn it back into the soil and keeping the organics there. But from a standpoint of being a farmer and what he has to do as far as making living, they're actually making more money on the straw now than they make on the grain in many cases. So a lot of uses of straw and a lot of, we actually manufacture a wattle out of virgin bales of straw. This, by the way, is roughly what we may use in a year for straw. That's what our supplier sent us when we asked him, do you have an idea of how much straw we use in a year? And he sent us this picture. It's a little more than we use in a year, but it's a lot. And that's, I'm going to say Manitoba. So straw wattles are good for facing silt fence. When we first started doing this, we put in silt fence, we put a hay bale in front of it. Some states required it in back of it. In front of them, I think is the better application. But we've really phased that out because of the price of straw bales and hay bales now. And we're using a lot more straw wattle as to face that silt fence, and it works fairly well. If you take why this works in a small, because I looked at first, we used hay bales and that made sense. And now I put a small wattle in front of it and it does effectively the same thing. Didn't make a lot of sense to me at first. But what you're doing is you're taking the first contact with water away from the trench that you dug to put the silt fence in. That's where most of your damage gets, where your undercutting happens and where you have problems with your silt fence. So it does work very well. That's pretty much been an industry-wide change now. There are still people putting in silt fence and hay bales, but that is a very costly application compared with doing some of these other ones now. Water diversion, if you just want to divert water, a straw wattle works great. I still use them as a standalone perimeter control in an area of low risk, where we don't have much chance of any thing being a problem, and as slope interrupters, as I showed you in this this application. This works out really well. We worked on this at again, this is the Elizabeth mine. We would put the wattles in. We weren't really even keying them in, but then we were shooting our hydroseed application, which was a high-end hydroseeding application over the top of it, and it locked them in really well. I actually had a Army Corps guy who hadn't been on the job site for very long. We sprayed this whole cut, and we had a tremendous amount of rain day after we put it in, probably 2 or 3 inches of water over the course of a couple hours. And he came running out there the next morning and he was just standing there and I wasn't sure what his issue was. And I walked up to him and goes, "Is there a problem?" And he goes, "I can't believe that none of this moved." I'm like, well, it's taken us a long time. I was there for 10 years developing what we were using between the engineer and I for this type of application. But when you get people that tell you there's nothing I can do, there are things that you can do. So straw wattles, some of the disadvantages, people just started making straw wattles because they were making blankets, straw blankets. As you can imagine, if you weave straw into a blanket, there's a lot of stuff that lands on the floor. They were looking for something to do with that. They stuffed it in wattle netting and they started selling it. There's no real research. There's no studies behind it. There's been some small stuff, but really through field work, we know that it works. And so that's pretty much been the way it's gone. It's a sediment only BMP. We're going to talk about other things. Compost is an amazing thing. I'm sure you all know that, but we can do a lot of things with compost that we can't do with other products, and straw is one of those things that we just can't do these things with. Flow through rates may be as high as 3 to 6 gallons a minute. I talked about, I've tried to locally source as much material as I can, but as we grew bigger, we've had to go out to the Western states to get our straw as well. And about a year's life expectancy. You're not going to get, if you've ever seen a straw wattle that's been in the field for a year, It's just a mess of goopy stuff inside some plastic, and not really performing any function at that point. So now I want to get on to compost. This is beautiful looking compost with some stuff growing into it, and I'm going to talk almost nothing about that, because most of our products are not designed around what you would consider compost. And I will tell you that to a certain extent, a compost sock is a bit of a misnomer for what we're doing, but I'll explain why in just a second. The first thing I wanted to talk about, though, was 2-inch compost blankets, which I've done a ton of. That's 2 inches of 1-inch minus evenly graded compost with seed mixed into the compost. And then in my case, we were blowing it in place. It can replace up to 4 inches of loam and seed. No additional cover in most cases is required. So everybody wants me to do other things to it. You just blow compost on the slope, and that can't be all we need to do. But if it's the right structure, and it's again 2-inch minus, 2 inches of 1-inch minus compost, it works extremely well. And I'll show you an example in just a minute. This is what it would look like when it's on the soil, and it is laying on top of the soil. The roots and all will drive that, integrate those layers fairly quickly, and becomes a very sustainable application. This is one of the first things I ever did, and I ran across this slide, so I threw it in here. This is at a composting facility in New Hampshire. He wanted to see how a compost blanket would work. He's basically in a gravel pit, so we took a gravel pit and we blew socks, and then blew a compost blanket. This is about a week later. All right. With very little rain, actually, which I was surprised about. The one thing compost blankets need is, to be watered fairly well. This is what a more commercial application would look like with a blower truck, and we're blowing 2 inches of compost onto a site. This is the site that really kind of blew me away with how well a compost blanket would work. I know they worked fairly well. That's hard clay. They could barely stand on that slope because it was wicking water out of it. We blew 2 inches of compost on it, and you can see in the background there, within a week, it was pretty much, at least all the grass was starting to germinate. And this is what you'd get after about a month or so. We had a few problems here, but not many. We also had our Mother's Day flood, which if anybody was familiar with that, we got about, this site got about 13 inches of rain in 36 hours, and had one failure. We had about 8,000 square feet that we blew right up until it started raining on Friday, and we had water underneath it. And eventually, after about 9 or 10 inches of rain, that did slide off, but it saved the slope. The slope, wasn't damaged. If you went around and looked at other people's sites, we had huge problems. That was the only damage we had on that site, and over an acre and a half that was complete. So we really considered that pretty much a success. And it was compost, so it all fell to the bottom of the slope. Picked it up with a loader, we put it in a pile, we dried it out, and we put it back on the slope. So very little, damage. I just threw this slide in because when I go on vacation, I take some erosion control pictures. This is actually in the Dominican Republic on my way to Haiti. And this is their idea of erosion control. Okay, they put a whole mess of drainage underneath it and then spray concrete on the top of it, and I'm sure it works. Not the most appealing thing to look at, and not very ecologically sound in my mind. We're certainly not storing any rainwater there. So where do we go from there? So compost berms have been around for a long time, or as Maine called them, erosion control berms, or erosion control mix. And this is just a well-graded mix. So Maine has a large logging industry, and they had a lot of wood waste fines left over from that. So, and they have, trout and salmon that can't, New Hampshire, we're the granite state. We put granite everywhere. Maine didn't want to do that because you heat up the water. We've learned not to do it, but But they were looking for ways to control erosion without heating up water, which is what you do with a large, riprap slope. And so this is a very coarse mixture. This is not very refined. It's the organic material content is between 80 and 100%. And you'll see 100% passing a 6-inch screen, 70 to 85% passing a 3/4-inch screen. I want to point out the organic portion needs to be fibrous and elongated. That's really important. People will sometimes use chips on a job site, and chips can be part of some of the mixes we use in our sock, but you really want grindings more than chip on a lot of these applications. This is kind of what it would look like. That's was stolen from a supplier site, and I'm going to say that inset picture is probably a little cleaner than most of the erosion control berms that I've seen. And this is what you'd see if you spread it out. And this is kind of where our compost blankets came from, was this kind of technology. And you can see over in the left-hand corner there, a berm, and you can see some of these berms get pretty tall. And one of the real problems that Maine has with these is, that berm at one point is almost 3.5, 4 feet tall, which is great for erosion control during the job. But when you go to vegetate that site later on, growing vegetation in that wood mix is not that easy a thing to do. But Maine is still using these today. This particular site is a wind farm up east of Bangor, Maine, and they had no silt fence, no socks, no anything, but they had erosion control berms everywhere on that site, and they worked very well. And I encourage people to do that today. If you have grindings on site, if you're grinding your stumps, use them for soil cover and for creating berms where you're allowed to do those things, because they're great ways to stabilize soils with products that come right off the site. So I want to get into a little bit more on where tubular mesh products started to fill in. So we always knew about straw wattles, and so some people started looking at, well, couldn't we put compost inside of a sock, and wouldn't that work as well? And so we started looking at those erosion control berms and how we might refine them a little bit. So we basically took the flow through rate and the filtration capability of those berms, and then we created an optimum performance zone, and that's where we kind of started to build specifications for material that would go inside of a compost sock. I need it to be coarse enough to allow water to flow through it, but I need it fine enough to be to collect sediment, if you will, both inside the sock and behind the sock. Now, why don't we want to use a more finished compost? Anybody want to think about what's one of the best things about the compost that we make? Don't they have a nutrient content to them? Isn't that something that we really want to have in our compost? But I don't want it in my compost sock. Okay, I see Josh vigorously shaking his head. That's why we use a wood fiber. So these are wood fiber berms. These are not what we would call compost berms. I'm going to show you some compost applications in the near future. But for these applications, we're really talking about a composted wood fiber. Chips, grindings. I use chips and grindings together, honestly, in a mix that comes up to meet our spec. It has enough of those elongated fines in it that we're going to catch a lot of sediment. But the chip, it's almost impossible to get a grinder to make a mix that will actually meet that optimum performance zone spec that we make. So we add a little bit of wood chip to it to do that. At any rate, that's why we're using wood grindings. Now, this is a beautiful picture, but if I took that mix and I threw it through a screen, I'm going to tell you that mix right there does not meet the spec, that would be in that optimal zone. This is still a little bit fine for what I would want. So when you see people putting bark mulch into a compost sock, we're really creating more of a dam than we are a filter media. So, media types, particle size, storage capacity, all those are things that we've looked at when we create that mix. And we've done a lot of third-party testing, and other people are doing third-party testing as well. Those are all questions you might want to ask if you were speccing a sock on a job site. Why is the mesh important? I used to say, like I said, when I got into this business, we had one mesh. We used one mesh for everything. Today, I'm going to say there are at least 6 or 8 meshes that I can think of off the top of my head, both plastic meshes as well as different types of biodegradable meshes. Even within biodegradables, we talk about cotton now, burlap, some of these deconstructed wood fiber products that we're looking at now. So all of those are different, have different applications, different purposes. So the material is important. What's it going to be used for? How long do we need it to last? What size and diameter, do we need? And most of the products, this is one industry that I'm pretty proud of. Most of the products are still coming out of the United States. There's very little of this product that's being shipped in from Canada, especially during the pandemic. I know we had broken down and we were going to use a product, a fiber that came from Canada. The pandemic saved us from that because it stopped us from using it because we couldn't get it. And we were able to find another source that was in the United States. So those are all things that we look at. So I am going to talk just briefly about what I do. I use a couple of different products here. All of this was designed around using compost overs. So the idea was that the two guys, there are two people that really drove this in the beginning. I think both of them are out of the business now, but at any rate, they were really looking at using coarse compost overs and finding a purpose for those to save money in their composting process. The problem with that is, as many of you probably know, it's very difficult to create a compost overs product without too much contamination in it. If I'm going to put something into the field, I can't have it full of plastic and full of, a lot of other things. So I use very little compost overs. There are a couple of things that I try and use compost overs for. But a lot of it is, grindings and chip, and then mixing them into blends that work on for construction. In the first 2 pictures, we're doing a lot more with stormwater now, and in that case I really do want a more aged, I really am trying to find when I can, a good source of contaminant free overs, and then we're adding products to that to pull out specific things. The things that we're adding are not they're not any of the things that would be used for, they're not coagulants. They're not, there's a word I'm looking for that I'm not getting here for the moment, but so they are looking to attract whatever it is to them, usually through an electronic bond. And then the last picture there, we do use some what you would call compost. And I still want that 1-inch minus. I pretty much, for most of my applications, want a yard waste compost with very little nutrient content to it. It's a delicate balancing act that I use to get vegetation growing in that, but still keep my nutrient content to a point where we're not going to get a lot of leaching out of that before we have vegetation, which is hopefully going to lock all of that down. So the way these all work, this is a Filtrexx slide, and I apologize for using a Filtrexx slide, but it is a great slide of how these things work. basically we want water to pass through that. We're going to collect sediment behind that sock as well as within that sock, and then pass relatively clean water out the other side. I went too far. So all of these other applications now that we use, can use composted wood fiber for, check dams, inlet protections, perimeter control. We're going to talk about a little bit of some of this stuff. That central picture there is a concrete washout. And I was at a meeting one day, this is a long time ago, and they kept talking about concrete washouts, especially in the Southwest. That's a big deal because a lot of the stuff that's in that concrete can really affect the soils out there because they don't get that much moisture. Basically you're creating some kind of a container and you're doing all of your washout with your concrete into that. I sent them a concrete washout from New Hampshire when I got home, which was the foundation hole, and they had done their work and then they washed out in that. But you're seeing more and more of this now in New Hampshire and all over. So how these products were installed when we first started installing them, we used blower trucks, and that picture is Otter Creek. That operator is looking at the Killington gondola, and this is the second job we did, I think, in New England, and it was very successful at the time. And we do a lot of that type of work now. Now, typically it's done with 8-inch sock and it's done off of pallets. So we did it for a long time like that. And I was a blower truck guy for a long time, and I'm like, pallets, that's going to be cute for doing a couple 100 feet, but nobody's ever really going to use that on big jobs. I can tell you now that 80% of the roadside work that's done is done off of pallets. A lot of it now being done with biodegradable product. Just goes very fast. The logistics are easier. And I'm not saying there aren't places you're going to use a blower truck, but there's more and more work being done off of pallets every day. So again, that's the picture on the left is Otter Creek near Killington. And then that other picture is in Burlington on a laydown yard for a road job. I'm talking early 2000s here, maybe 2003, 2004 when we did this work. And that was all done with this HDP plastic sock. So, and I would encourage you not to use this anymore. To be honest with you, we still sell it. It's still used in a minimal cases, but this is HDP plastic. It starts to break down almost immediately, and will be totally broken down within about a year to 18 months if it's exposed to sunlight. And a friend of mine who's a chemist, I did a talk on biodegradables and non-biodegradables, photodegradables, and all of that. It sounds simple, but when you get into it, it's not simple at all. But during that talk, he was like, well, it's photodegradable. It goes away. And I'm like, but Chris, doesn't it just break down into a lot of little pieces of plastic? He goes, yeah, and they get smaller and smaller. I'm like, you need to go to a couple of the talks that I've been to because that's not a good thing. So we don't use this much anymore, as much as we used to. It's hard to recover at the end of a job site. There are a lot of blower companies that are still using that, and it's still effective, but we are seeing more and more people moving away from that. And this is what one of those applications would look like. This is Lake Winnipesaukee. This is where I did most of my work early on in my career because that's alongside the lake. It's forest stuff and rock. It's very hard to install silt fence. Typical silt fence installations where we would dig a trench, put the silt fence in, and put rock in it, which you're taking the shoreline along the edge of a beautiful waterway and throwing a whole mess of rock at it, which the sock helped avoid. So we got very popular there for quite a while. Palletized sock came along, we started developing it in New England here at about the same time Filtrexx did. And that's a friend of mine who was just here yesterday. He works for Filtrexx. He always wears a shirt like that. Doesn't matter what he's doing. He's always dressed well for the job. At any rate, basically you're looking at a palletized application. You're going to need to get equipment fairly close to it. And that piece of equipment backs away and you put the pallets down. Like I said, most road work gets done this way. I'm going to say the lion's share of it, Massachusetts, Vermont, all want biodegradable now. We were putting out 2 trailer loads of biodegradable 8-inch sock in a day to replace what I was doing with that blower truck. So where I did about 2,000 feet a day with that blower truck, they're literally doing biodegradable sock at a rate of 4 or 5 times that now. With palletized product. And this is what our cotton would look like as opposed to our traditional material. That material is very strong, will not photodegrade very quickly. You can remove most of the plastic, but you will start shedding plastic almost immediately. So you're gonna have some degradation in that. This is a biodegradable application early on, one of the first ones we ever did. And then we make extreme meshes. So if you want to use sock for, we get these used quite a bit on at road entrances. If you want to close a road entrance off every night, we make this extreme fabric that'll hold up to being drug off and on the site every day. So just, again, this isn't a one-time thing anymore. We're doing a lot of different things as we go along. So I wanted to talk a little bit about some of the other things that are out there. These are inlet protections. I don't know if you're familiar with any of these, if any of you are doing erosion control. But these are some of the hay bales down in the bottom corner. Not a lot of flow through rate. This particular job site, he had hay bales around all of his inlets. This is a very long time ago. And we had an event and he almost lost his detention pond because all the water went past 12 of these and jumped the curb and went right down into his detention pond. Almost took out the other side of the detention pond in one storm event. So we came in and did some sock work for him. But you can see some of these things, none of these things are going to flow water very highly. And it's interesting because I'll talk about the bags that they put into the inlet and then you drop the inlet back down. Those are very cumbersome. Once they're in, nobody's ever looking in those to see if they're full. Once they're full, it's almost impossible to get them back out of them. It's a joke in the industry, but most people are going around and cutting those to get them out. All the sediment's going right back into the basin. If they're maintained properly, it's just like everything else in the world. If they're maintained properly, then they work, fairly well. If they aren't, then they don't. Putting silt fence around them, that silt fence flows at about 1 gallon a minute. I'm sure that inlet was designed to take a lot more water than the 8 or 10 gallons a minute that silt fence will allow through it when it's first put in. So we've started doing some other things. This is an early application that we use like that. This is a sock. That's a coir pad. This one, in this particular case, uses zip ties. So you pull the inlet cover, you put that coir pad on it, drop it back in and put a sock around it. I'm going to say it takes no more time than putting that bag in the inlet, but holds up much, much better. And all of that is, so that's a coir pad. The only thing that is not biodegradable there is the sock netting and the zip ties effectively. So all of that can go. Now they're making them where that coir pad actually has magnets on the bottom of it. And so you literally just drop that onto the inlet and walk away. they use that as a standalone. I prefer to have a sock, either on the upstream side of that, or in this case, this is a kind of a basin. So, we've got it at the bottom of the basin where the water will collect in there. Now, yesterday I was out in our backyard, has an application very similar to this. When I was out there, when it was pouring rain, we had probably 2 or 3 inches of water starting to build up around that inlet. And within an hour, it was all gone. So this is a very, I like to call it a bomb-proof inlet structure because I haven't really seen one that's failed yet. So if you see one that fails, I'm open to, seeing what happened there, but they work extremely well. Now I want to get into a little bit more of some of the, no questions yet. Wow. I'm either putting people to sleep or.
No, it's good. You're going at a good pace and covering ground. But folks, just a reminder, at any time, go ahead and put questions into chat, and I'm monitoring that. Or you can also raise your hand and just unmute and ask your questions.
Sure. So wanted to talk about pollutant removal. This is a job site that I've worked on for quite a while. Talk a little bit about that stormwater sign in just a minute, but these are some of the things that we're targeting here. Nutrients, bacteria, hydrocarbons, and in the case of this site that we're looking at, this is heavy metals, zinc in particular, but a few other things as well. And this is what it looked like when we first started attacking this. So this is a foundry. It's in Milford, New Hampshire, and they were having a zinc issue. So we blew these. This is the outlet to their storm drains. Oops, excuse me. The outlets to their storm drains are right there, and so we put it through a series of speed bumps, if you will, and those all had a metal locking agent in them, and that's what it would look like when we were having a decent storm event. So it's working. It was reducing the zinc by quite a bit. This was about 10 years ago, and I never heard from them again. As they went through a couple of different engineering firms and a couple of other things going on, I did want to point out that stormwater sign. So I'm assuming that everybody here understands what do not mow means. Their
Safe
landscaper
assumption.
did not.
Mm.
So after we put about $400 worth of, so this is not just the socks. We actually put the socks in, and then we put, we actually, after we saw this, we created a 4-bay. So we had some water detention underneath, and we planted blueberries and yarrow and a whole mess of things that we thought would help with the zinc issue. And then we put some other things in there because the property manager was concerned that it would look just like a weedy patch. And so I probably had $600 or $700 worth of plants in there, and they did not mow it. And they must have thought, well, it's too wet to mow, so we'll just string trim it. And so they string trimmed everything that we had put in. And I got a call from the property manager and goes, none of those plants you planted came up. So I sent him a picture back of all of our plants mowed down. He wasn't very happy, but it was, we fixed it in the end. So that project went along, and about 6 months ago, I got a phone call and go, we need to do something else at that site. And I'm like, I'm sure that those socks that we put there can't be looking very good at this point. So we've come up with a plan now. We're doing a little bit more there. We are going to, hopefully within a week, go out and mow that whole area, and we're going to put some new socks in and some new, we're going to kind of refine the way we move the water in that area, so that we get more contact with the socks and we have a good spot for them to collect water for their samples. We also went up on the roof. So this is the roof of that facility, and we've put 10-foot sections of sock around every one of the drains. This is, again, our industrial blend with a metal locking agent in it. It's a more composty type material to slow the water down a little bit. And I hope to have more information on how well this works. I've always wanted to do this, and I haven't gotten any panic phone calls during all of this rain. So apparently all of the drains are working fairly well. But I think this is going to be really, I honestly think a lot of their problem is there's a lot of sediment in that rock and there's a lot of ash. They had an issue with one of their dust collectors and there's a lot of dust landed on that roof, which is now all coming off the roof. And I really think that after I listened to all of that, that maybe just putting some regular sock up there might have solved our solution. But I'll have more on that as we go along. But certainly the install went very well, and we're happy with the results up to now.
Hey,
These
Jack,
are just
I have a question. So you're talking about the metal locking additives that you put in that it chelates it somehow. Is there like a maximum capacity after which it's full that
yes.
that would need to be replaced? Can you talk just a minute about like what, like I'm sure it depends on the rate of what the level of contamination is that it's filtering.
Right.
But what is that? And then what happens once it's full of whatever that contaminant is?
Good question.
Where
That's
does
what
that sock go? Yeah.
Well, whoever that is so this is a cradle. That's very good question because this is a cradle to grave solution, if you will, for this product. If you're going to use this application, you need to know what you're collecting, what's inside that sock, and how you're going to dispose of that sock afterwards. In most cases, with most heavy metals, it will now be contaminated with heavy metals, but they're concentrated in one location and should be disposed of as you would any other material that was, contaminated with a heavy metal. So you're going to be removing it. Well, we're trying to concentrate that and remove it in one location. Same thing with when, so this is our advanced blend and this is our industrial blend. People don't understand. Let me go back just a little bit. People don't understand about these. Come on, you. Yeah, it's not gonna. At any rate, when you look at that drainage swale, I want you to harvest everything off of that drainage swale once a year and dispose of that as you would a contaminated heavy metal, because the plants I put in there are designed to pick up whatever that is. So we want to be making sure that we're doing it. People are always talking about different plants and their ability to pick up metals. And there are a lot of good plants that pick up metals. But if we're not harvesting that material and taking it away, then all of that is just decomposing back into the soil, and it just becomes so it's a very, how do I want to put this? So you're dealing with an engineering factor. Engineers are very uncomfortable when I start talking about we're going to plant some plants and the plants are going to pick up this stuff and we're going to, because they want to see a concrete structure and they want it, and we're filtering something with a mechanical filter and they understand all of that really well. They do not, as even, I've done a lot of drainage swales and they're like, your drainage swales are great, but I can put riprap down tomorrow and I know that it's going to be 100% effective to the way I have it designed. You're going to plant something and I've got to wait for it to germinate and grow before I know whether it's going to be effective or not. And I'm like, yeah, but it will be more effective than your riprap in the long run. But it's very uncomfortable for them to go through some of that, to really understand that. I used to do a lot of work with a lot of this kind of stuff and stormwater basins and rain gardens. Rain gardens were one of the biggest things. I was talking to an engineer one day and she was saying, well, yeah, but people are going to fertilize it and they're going to do this and they're going to do that. And I'm like, well, why can't you write a spec that says that they're not going to do that? There should be maintenance done to a rain garden, but it should be very specific. And if I put in some $3 million mechanical extractor, it's going to have a set of maintenance that goes with it. And I think that's where people are starting to come into doing more of this with rain gardens and all of that, where I'm going to put in a rain garden that's going to have specific plants in it. You need to do this, this, and this with it. You're not going to put a mulch with colorant in it, and you're not going to fertilize them, and you're not going to, because you shouldn't have to. We're designing a system that doesn't require any of that. But from an engineering standpoint, it's very uncomfortable for them to really understand how that all works. But does that answer your question?
It does. Yeah. Thank you.
So again, these are all things that we're doing on those stormwater inlet things. This is not a construction thing. This is, again, attacking those heavy metals and all of that, but that's compost inside that filter, inside that drain. So it's a drainage feature. It has a compost filter in it. They're relatively easy to install. We haven't done a ton of these, but we are starting to see some results. So that filter drops right in over the top of there. And again, we're seeing some pretty significant results out of those. This is the way it would go in. Those top pieces are made out of metal now, but the ones I've gotten around are working fairly well. So now I'm going to start talking about actual compost. Is that exciting or what? So this is a living wall. This wall is, this is an MSE wall. So this is a mechanically stabilized earth wall. It uses a geogrid and a compost sock to create a permanent wall application. And the idea of this is that all the plastic in that is going to be under a layer of vegetation where it's not really going to be able to break down. Probably very difficult to get in Vermont right now, and rightfully so. I'm looking at some ways of doing this with long-lasting materials that would biodegrade, but are going to biodegrade over a long period of time. I can still make this wall, I think, with biodegradables, as long as I get the right vegetation that's going to eventually lock that all in place. But we're kind of right now working with inorganic materials to create the structure of that wall. And this would be an example of this. This is Springfield, Massachusetts. This is an outlet to their stormwater system. And typically this would be done in with riprap. In this case, we used a blower truck and we built this wall. I always want to build these things in like July and August, and this was the week before Thanksgiving. Very, very cold, inhospitable time of year to be doing this. But we installed it. It didn't really germinate at all till spring. But this is the way these things are installed. Geogrid that goes way back into the bank, and the geogrid wraps around the sock and is compacted and lasts very well. So you can see here, they're just going to put that fill in there and they're going to rake it up against the sock, and then they're going to drape the material over the top of it. Those socks all have a 1" minus evenly graded compost in them. And they have seed, no fertilizer in this because we're right next to the river. So, and I'm using an all yard waste compost. So, that I know has very little nutrient content to it. This particular wall, because of where it was built and the way it was built, we used a little bit of cool season grasses with a native grass mix. And then we were going to live stake it the next spring. By the way, it took us about 2 days to build that wall. So if you're going to build a block wall here, if you know anything about building that, it would have taken probably twice that long to build a block wall there. But at any rate, that's what we, about how long it took us to do that. This is what it looked like in April as those cool season grasses started to come in. I got a little nervous because the cool season grasses were doing really well by May. But by August, you can see all the natives are really starting to take over. A lot of our live staking had taken over. And the only problem with that is where I'm standing. there's a whole mess of Japanese knotweed just itching its way to get into that wall. And there is some maintenance being done to that wall, so I hope that we can keep the Japanese knotweed out of it for now. But at any rate, it was a very successful application. So I don't know how many of you're familiar with gabion baskets. My friends in the gabion basket industry hate it when I call these chicken wire baskets, but that's effectively what it looks like. It's a big chicken wire basket filled with stone. And that wall there is the bridge going into Haiti from the Dominican Republic. So this entire river is lined with these gabion baskets for as far as you can see in every direction. Not the prettiest, even though those are pretty well done and they've done a good job of placing rock in the front face of them to look like a rock wall. Not the prettiest looking thing to look at. But we've started doing some of these where we're taking compost sock and putting a compost sock in them, using a dirtier stone in the back of it so the roots have something to grow into, and placing them in the field. And this is what you get after a period of time. So you're not looking at a gabion wall at all. This wall's been in a good 8 to 10 years now, and it's doing fairly well. And I've got one that we just put in last year in Merrimack, New Hampshire, that you can really not see the gabion baskets anymore after a year and a half of growing. So another application, again, probably not acceptable right now in Vermont, would be hard to get installed. The problem with gabion baskets is gabion baskets have got such a bad name for themselves because they look like that rock wall. They look like a chicken wire basket full of rock, that a lot of people don't want to use them. I think they might be more acceptable if we saw more of them like that. This is Girls Brook. This is Hanover, New Hampshire. And this was actually designed around gabion baskets. The gabion basket prices came in very high. So we redesigned it using that GeoGrid and sock application. And we built these. And then the sidewalls to that were all put in with compost blankets and lockdown netting, so it held them in place. And I don't have any good pictures of this. This is September of that year, after October of that year, after about a month of grow-in. This looks like a kind of a meek and mild application, but I have seen this with water running over that whole structure. We've had this took hits from Irene and Sandy and a few other events, and there's an impressive amount of water that comes down this stream when it's running. And they made me put all of that stone in. This was originally designed with all compost blankets. They made me put in that stone because they saw one 3-inch rain event we had that filled that trench just before we built that structure. And the engineers in charge kind of panicked and said, we need to put stone in. That was what it looked like after a year. You can't see any of that stone anymore because that is all working so well that we're getting sediment deposition over all of that rock. And that is now just, all vegetated at this point. Now, if you get a really big sandy type event, that is going to strip some of the vegetation off of that sock. But the roots and crowns of that are all down inside the material. So they will, over time, grow all back in. This is actually after, one of the Irene, I think. So really been a successful thing. Again, all of the plastic in that application is down underneath all that vegetation. In 10 years, I haven't seen any degradation in that at all yet. This is another, probably one of my last examples, but this is so the person in the foreground there is Trevor Smith. He used to be president of the Ecological Landscape Association. And I came out of a meeting one day and my phone is just blowing up. It was like bing, ba bing, ba bing. He was sending me pictures of this slope. And so he sends me like a dozen pictures and then he goes, I don't know what we're going to do here, but if anybody can come up with a solution, maybe it's you. That's our access in that top picture. They had built beautiful granite walls till they ran out of money and then left this half to one to one to one slope above it with no protection really on it at all. And it was eroding down onto the patio there. There were rocks that were hitting the house. It was quite a nasty situation when we got there. We basically built up this application, which is GeoGrid and SOC, but it is not, the GeoGrid does not go into the bank. We're just doing a GeoGrid wrap on the SOC. And we did that about half, 3/4 of the way up the slope, pinned it in with duckbill anchors, and then we put a Flexterra application on the top of it, which had very little organics to it, and I knew wouldn't work very well. This is what it looked like after it got done. Again, there's no organics on the top of that. There was grass there. You can't really see it in this picture, but not a very good stand of grass. I did use a product that is a compost alternative that's sprayable, and we sprayed that, and that's what it looked like after it was done. Now the top of that has started to naturalize. You couldn't get any equipment to the top of that, but it's kind of fallen in and naturalized now, and looks pretty good. So that is pretty much where I'm at. Now I know I ran through some stuff. I'm probably quicker than I went quicker than I should have. This is Haiti. This is Sedona Forest, which is, if anybody wants to know more about Sedona Forest, they're welcome to get a hold of me. Sedona Forest is a private nonprofit that plants trees in Haiti, India, and Kenya. And I've volunteered at their facility now 3 years. I haven't been in a while. I kind of want to get back there. It's time for me to get back there. The first year I went, I always do a project when I'm there. So I've built 2 buildings while I'm there. And then the first year I went there, I was just kind of getting my feet wet. So we built this gate. I met with the guards who wanted the gate. It is Haiti. It's a very safe part of Haiti, but it's still Haiti. And of course, they wanted a big iron gate with barbed wire on the top of it and all of this other stuff. And I'm like, I'm not building a big iron gate with barbed wire on top of it that represents a vegan tree planting organization. We're just not doing it. So there happened to be a woman there who was an architect from Israel at the time. We designed this gate. It's a strong enough gate, but we put pots with cacti on the top of them. And I can tell you from doing some clearing for some other work I've done there, I would much rather try and climb across barbed wire than those cacti. And those are still there. They were there 3 years ago when I was there for the last time after 3 years. So my point in all of this is green infrastructure does not need to be complicated. It just takes a little imagination and a little bit of time. That's my final message. This is my favorite turtle picture. For anybody who hasn't heard about my turtle picture, early on when we did this, we had a site where they wanted turtles to be able to cross the sock, and I got a panic phone call from an installer who said, "Can turtles cross the sock?" And I'm like, "I don't know, it looks like a log with little handholds in it. I think they can cross it fine." At any rate, this young man was trying to commit suicide in the middle of the road while I was out haying. A couple of nights later, I picked him up, I took him home, gave him a big lecture on that, took him out the next morning, and I couldn't get back fast enough to shoot these pictures. My point in this picture is that the nettings we use are very animal friendly, especially when we start talking about the biodegradable ones. I have never seen a negative animal interaction where there's an animal caught up in them. They're not a loose knit thing like some of the blankets are. And we've never really had a problem with them anywhere that we've used them. And that is the end of my presentation.
Hey, thank you so much, Jack. Folks, do you have any questions you'd like to ask? Go ahead and unmute or raise your hand or put it in the chat. And I just want to thank you, Jack, because I think you made the point really nicely. That is something that I talk about a lot when we do compost use webinars or workshops, is you need the right material for the right application to get the results that you want. And so, like the last thing you want to do in a lot of these applications for stormwater management is cram them full of like your garden variety, high nutrient, really fine compost. And so that's, it's like that not all composts are the same. And I think that's a really important message.
No, and even some of the researchers early on, there was some work done in the University of Vermont, and she was working with rain gardens, and her research basically said that compost leaches nutrients, which it will. In what she had designed, it definitely would. She had bottom drains in it, water was draining out of the bottom, and she was using biosolid compost, and she was using some manure-based compost, and I'm like, yes, I agree with all of that. And if
and it was also a saturated state, I think. So that's a very different thing.
It was a saturated state. It was funny because I have a couple of friends that really thought we were going to get into a big debate, and she and I talked for like 5 minutes, and we were like, yeah, I get what you're doing, and I agree with your results, and I understand what you're doing, and then your results are going to be totally different. So, it's just everybody getting together and talking about it. There are a lot of different ways to make compost. And it was funny because at the end of that, she goes, well, there was a company that came up with a compost that didn't really have any nitrogen and phosphorus content to it. And I'm like, it came from Rhode Island, didn't it? And she said, yes. I'm like, that's what I use in all of my, these applications that you're seeing along the water. Because we really want to look at that before we start doing those applications.
Yeah. Yep. Definitely. So Brenda asks whether the biodegradable netting is certified as biodegradable or compostable, or how are you, or is it just the material that
so it's cotton right now? Right now 90% of what we're using is a wax cotton. So yes, I mean, I don't know that we have a certification process that we put it through, but I'd certainly be open to doing that if anybody had it definitely. So it's interesting because the job that we did, the ones that you saw on that slope in at the Elizabeth mine, they did have us pull all of the netting. It was one of the driest summers we've had ever. So the top netting, all of the bottom of that decomposed away, but the top netting was still there. And they did have us pull that off, but it was literally taking 2 fingers and pulling, some material away. And I've had plenty of those that totally decomposed within, fairly short period of time. So basically all we're using, they did, and I've been approached with a lot of different products. There's a whole group of products that are compostable. So if I took that out of the field and I put it into a compost facility, they would decompose in a compost facility, but not necessarily in the field. Those aren't really acceptable for me. I need something that is going to decompose in the field.
Yeah. Not just hot compost compostable, but field rated compostable.
Right.
So Brenda, also just a follow-up question, whether the wax that's used is natural or if it's petroleum based. I don't know if you know.
That is a good question. Now I can look. I believe, and I was told, although I'd like to, I may look into that. It's supposed to be not a petroleum based product. I mean, the whole idea behind building that was building a natural compostable product that didn't have any petroleum products to it.
And another follow-up question. So it sounds like you guys are increasing and adding in, compost and burlap netting as an alternative. but why not just use all of that and not the plastic anymore due to increasing concerns about plastics in the environment? And I think that's what you were getting at a little bit a couple of times when you said, now this probably wouldn't be approved in Vermont. I'm guessing it's because of the plastic piece
So
there,
because of
but
the
can
plastics,
you
we're not
elaborate?
used in Vermont a whole lot, although I just shipped to, it's strictly at this point a supply and demand thing. People are still demanding that plastic.
Mhm.
And I am out here every day trying to talk not using the plastic as much as possible. But we are in a competitive business, and it was started around plastics. Listen, this has been the hardest thing to get people to understand. You got to understand most of the, we've been owned now by 3 different companies. 2 of those have been plastic manufacturers. So when they do plastic, they do plastic fabrics. So the fact that I want a biodegradable cotton material just blew their minds. They couldn't understand why I wanted it. And the only people that want it yet are New England and California.
Mm.
Everybody in the central part of the country could care less. Although even that is starting to change some. So I'm just going to tell you, I'm trying as hard as I can to change, hearts and minds, but it's a bit of a struggle. And I can tell you right now, we are making biodegradable sock tonight to go on a job.
Mhm.
This month is the first month we've ever sold more biodegradable than we have of the polypropylene. So we're making progress. There are some, I can take a polypropylene pallet and I can leave it in a field for a month or 2 months and go out and install that. The cotton, I need to get you to install it within 2 or 3 days. So there are more logistics to it, although we are working on that as well. I mean, I can generally get you product within 2 or 3 days, and I can arrange it with you so that when you're ready to install, we're going to have product there for you. So there's a lot of nuts and bolts to this when we get into using all, if you can imagine, if I take a pallet and I, get it all set up to go out on a job site, it's actually, I'm setting up a really nice composter right there. So I need to get it out in the field and installed. But from my standpoint, I would like to see us using almost all biodegradable products, and the states are moving that way. I mean, Mass, it's all by town and county, and we're moving a lot more biodegradable down there. Vermont is all biodegradable. New Hampshire, anything on so we have our alteration of terrain permit. So once it hits a certain size, it needs to have an alteration of terrain permit. That alteration of terrain permit now says that everything must be biodegradable, except for silt fence, which I would really like to go back and go, why is silt fence exempt from that? Because it's one of the worst offenders. But
And it's so
um,
rarely actually removed, right?
it's more and more, yeah, the more and
Mhm.
more it's getting removed. But as you saw in that picture, in the past, it was never removed. Um,
Mhm.
but contracts for erosion control from the time that I got into this business till now have changed greatly. 20 years ago, you get a huge road project and it might have $2,000 in it for erosion control. Now it can be up to 20% of a budget.
Yeah, I think that's a great call for consumer activism around, demanding and having, setting different standards and expectations, because that's, as Jack was just saying, that's, and we actually had a little bit of this conversation in the session before this one about the power of consumer demand, right? Whether we want cleaner products, biodegradable products, non-PFAS laden products, whatever that is, there is a
Right.
regulatory role for sure, but there also needs to be a market for it, and people need to be wanting and willing to purchase that and make that shift. So
Yeah, I think with everything else, there's an expense to everything.
mhm.
And it's getting people to understand that the expense of doing things naturally and biodegradably isn't really that much more expensive if it's done properly than anything else.
Mhm.
but people want to do things the easiest way possible. So,
Yeah. Yeah.
and plastics have always been the way to do that. So there's uh, some real work that needs to be done into changing people's minds. So,
Definitely.
but we want to start doing more things like, like using more biodegradable products wherever possible.
Mhm.
And looking at ways, like I know from my experience, it's about the way that we move product and how we work with people to get them, people were using biodegradables and they hated it when it first started. And Massachusetts was an early adopter because they go town by town, and all I need to do is reach out and grab one or two people on the conservation commission and we can change a town. um, and so they were early adopters on a lot of this biodegradable, and now it seems to be spreading throughout New England. I foresee where we're going to be. I was just talking to the owner of the company the other day, and I'm like, I can see where, 75-80% of our product within the next 5 to 10 years will be biodegradable.
That's great
That
work,
would be the
Jack.
hope.
Yeah. Yeah. Got to push from the inside and from the outside, right?
Yeah, I
Um,
mean, it's what we use now is good, but the tensile strength isn't quite what plastics have very high tensile strength. So for them to handle it in the field is very easy. But we're making progress. They're making progress on the way that they handle
mhm.
them. So that it's come down to, we're not going to be able to fight it anymore. There are people that are going to want to use it, so we got to figure out
Mhm.
how to deal with it. And I think that's basically, what it was. Eversource now requires all of their products to be biodegradable, which I have a bit of a concern with. So if I'm going through a wetland and they're going to consider my sock wetland fill, I would actually like to see them use a plastic sock, because then I can easily remove all of that material from the wetland. But other than that, it should be all biodegradable, especially on a power line project where it could be miles and miles from where you're going to get it. So right now they're using all biodegradable, and they've got to take that all out by hand afterwards, which I get a lot of complaints from contractors about, but
Yeah.
it is what it is. So we
Great.
are making
Well,
some real progress.
thank you so much, Jack, for being here and for the session, and to all of the participants for joining us in this session. I know there's a lot of learning happening this week.
Well, thank you for having me. And
Thank you, Jack.
you and I have been collaborating on a few things, and we'll be collaborating on some more things hopefully this summer, and getting the word out. So if you want to see some of this biodegradable stock in the field, you'll get some good opportunities to do so as the
Hopefully this
summer
season.
progresses.
All right.
Absolutely.
Great. Thanks, everybody. Have a wonderful evening.
Thank you.
See you in the morning. Bye-bye.